Good day to all. Today we are going to see about the amp converting configurations. See here, it's a current to voltage converter amp voltage to current converter amplifiers. Before we are going to this topic, current, as already we know, that's a flow of electrons which is denoted as current I. And the voltage V is nothing but the potential difference between the 2 points, and it is denoted with the V. Okay, here this amplifier will have a current to voltage converter. Here this negative part have a input current, and a positive part in that amplifier you will connect with the ground. Then it will have resistor feedback. The output voltage will have the voltage here. So the formula for that current to voltage amplifier is V out is equal to minus of input current into resistance. Already we know that Ohm's law, voltage is directly proportional to current, and V equal to IR. We can remind this formula V equal to IR. The same thing will have this formula V out, output voltage, is equal to negative sign of input current I in into resistor. That is the current to voltage converter here. Then the voltage to current converter. Here in that negative part we will have a connection of ground with that resistor, and that positive point will have a voltage with resistance, and will have a current over here with resistance RL, which is connected with that ground. Then again we'll have a resistor feedback from the negative side, as well as the positive side will have a resistor. So from that formula, as I said before, Ohm's law V equal to IR. In that, how we can find out I? If we'll keep I in the same place, then R will go to denominator point. So I equal to V by R. Here the same you can see here, voltage to current. The formula for that find out that voltage to current is equal to IL is equal to V in, V input voltage divided by R. R is nothing but the total resistance. Then the instrumentation amplifier. See, this is the black diagram of that instrumentational amplifier, which robust differential gain amplifier. We'll have two voltage here, which is voltage 1 and voltage 2. The negative part of that amplifier connected with that resistance on both sides with the output. The output side will have a resistance to resistance, as well as the output voltage. The positive points will have a voltage 1, voltage 2. This is for the input stage, and the gain stage is we will have a resistance R3 and feedback R4, negative side with the connection of output voltage, and then there is an intermediate resistance between the positive point, and R3 will have a resistance 4 with the connection of ground. You see here, this is the input stage. This one is high input impedance and buffers gain stage. No common mode of gain is happen here, and then have a differential gain over here. Whereas in that gain stage, differentiation gain as well as low input impedance. See here it is a high input impedance and here it's a low input impedance. The overall amplifier is the amplifies only the differential component, high common mode rejection ratio, high input impedance suitable for the bi optional electrodes with high output impedance. The formula for that total differential gain is equal to GD equal to 2R2 plus R1 divided by R1 into R4 divided by R3. The instrumentation amplifier will have a with buffer filter. Before it, there is a no buffer filter. You can see here for this drawing there is a no buffer here. There is a no buffer here. Whereas here it is with power filter, PV filter, buffer filter. This part is instrumentation amplifier and this is the HPF and this is the non-inverting input amplifier. And the connection sensor to that microcontroller. Here it is a sensor and microcontroller which is signal timing memory. If we are giving the input to the keyboard, then we will get the display from that output. Here the analog, here it is for many microcontroller have a built-in analog to digital converter and this is the 8-bit to 12-bit common. Many have a multi-channel analog digital inputs. Whereas in digital serial input output over there, use serial input output port store in a memory to analyze and synchronize with that clock. Must match byte format, stop or start bytes, parity check, etc. Asynchronous, which is a no clock, more common than data. Must match baud rate with the bit width, transmission of protocol, etc. Which is the digital microcontroller. The connection of smart sensor to PC network. How we will have a connection with that smart sensor to PC network? See here, smart sensor is nothing but the sensor with built-in signal processing and communication. You can call the smart sensor. For example, combining of dubbed sensor and microcontroller are all and control the smart sensor. Then DAQ, data acquisition card. PC card with analog and digital input output. IO means input output and interface through the lab view or user generator code. These are the communication links for a common for sensor. Asynchronous serial communication. Universal serial communication. Universal asynchronous received a transmit of which is UART. One receive line plus one transmit line. Nodes must match with baud rate and protocol. Then the RS-232 serial port on PCs uses UART format but at in negative positive of 12 volt only. Can buy a chip convert from a UART to RS-232. Here it is a synchronous serial communication is serial peripheral interface SPI, which is nothing but one clock plus one bidirectional data plus one chip select, which is to enable. Then we can call it as the I2C. These are all the communication links, asynchronous serial communication, synchronous serial communication, I2C and IEEE. I2 means inter-integrated circuit bus. This inter and integrated, both 2I will have I squared. So inter-integrated circuit bus, which is for designed Philips for common inside TVs, used in several commercial sensor system also. Then IEEE P1451, which is sensor common standard, several different communication protocols for different applications. Thank you.